Number 25 shows an arrangement of resistors in a battery that looks something like this. The purpose for this 1 ohm resistor in here that's connected in series with a 10 and the 20 and right here next to the 15 volt is to present what is normally called the internal resistance of a battery. So it turns out that there's no such thing as a perfect battery, that all it does in a circuit is provide 15 volts in this case of electromotive power to a circuit. No such thing exists like that. So in practice, because batteries are real and they suffer from defects and even things like friction, you can think of it like that, that the battery itself presents a little bit of impedance to the current flow that it itself provides to a circuit. It's just called an imperfect battery. So what this problem wants to know is if you consider the imperfect battery with that 1 ohm resistor sitting there providing power to the circuit, what is the potential drop across this 20 ohm resistor here if the battery was a pure battery that did not have this 1 ohm resistor, and if it was an actual battery the way presented here that had the 1 ohm of internal resistance? So essentially, what is the voltage drop across the 20 in both of those cases? You just have to think about the internal resistor as just another resistor. So in the case that I've drawn here, that's exactly the way it appears here. What we have here is we have a 15 volt ideal battery here, then connected. The equivalent resistance of all the resistors, including the 1 ohm internal resistor, would be a 1 plus 10 is 11 plus another 20 is 31 ohms. 31 ohms here. So the 15 volts across 31 ohm, the current that would go through this thing is given by Ohm's law, which is 15 volts divided by 31. So the current that I get in that case there would be about 0.4839 amps. So in the case of having the internal resistance, it looks like 15 volts there are supplying current across 31 ohms, and so I'll get about 0.4839 amps traveling through this 31 ohm resistor. Now, to already get a preliminary answer to the problem here, if you back up, what this means is in this circuit here, this circuit as drawn here is drawing 0.4839 amps out of the battery. So if you thought of as current as going around this circuit like this, if this is some current in here, this current in the case of the 1 ohm resistor actually being in here is 0.4839 amps. That's how much current would be drawn. So you're right in a great position to calculate the potential drop across the 20 ohm resistor in this case here. You can just apply Ohm's law to it. The delta V across the 20, again, must be an application of Ohm's law. It's a 20 ohm resistor. The current traveling through it is 0.4839 amps. And so the delta V across that 20 ohm resistor in this case is going to be something like 9.68 volts. There's your first result right there. 9.68 volts. So with that 1 ohm imperfection in the battery, the potential drop across the 20 ohm resistor would be 9.68 volts. How do you proceed with the next part of the problem in the case that the 1 ohm resistor is not in the circuit? You just repeat the identical analysis here, but instead of this being a 31 ohm resistor over here, the circuit's going to look like this. The 15 volts is still going to be here, but now this is going to be a 30 ohm resistor here. So the current that this particular circuit is going to draw in the absence of that 1 ohm imperfection resistor right there, it's just going to be an application of Ohm's law. It's going to be the 15 volts divided by 30. So the current that I get in that case is about 0.5 amps. So in the case that the imperfection resistor is not in the circuit, the total circuit draws about half an amp right here versus the 0.4839 amps that you got in the other part. So there's a bit of effect of having that 1 ohm resistor in there. So the procedure now is the same. You can always use Ohm's law once again to figure out what the potential drop across the 20 ohm resistor must be. It's just going to be the 20 times the 0.5 amps. That's an application of Ohm's law again. V is equal to IR. And the potential drop I get in that case across the 20 is going to be about 10 volts. And so that's the voltage across the resistor without the 1 ohm resistor in it. Here it is with the 1 ohm resistor in it. I think you can calculate the percent difference between those two currents to be something like 3.23%. That's the difference in the two voltages.